In this second video on using the elimination method to solve a system of equations, we've got a very different problem. We've got the two compounds hexane and octane, and what we want to ultimately do is find the atomic weight of an atom of carbon and an atom of hydrogen. The information that we know from chemistry is that a molecule of hexane is made up of 6 atoms of carbon and 14 atoms of hydrogen. And for the compound octane, we need to chemically combine 8 atom carbons, 18 hydrogen atoms. So we can set up a system of equations to solve this problem again. And the first thing to do is we always want to identify our two variables. So we'll start by using C to represent the atomic weight of one carbon atom. And we'll use H to represent the atomic weight of one hydrogen atom. So going back to those two representative expressions for the chemical makeup, we know that for hexane, it takes 6 carbon atoms, and we add that to 14 hydrogen atoms, and that's going to be the molecular weight measured in grams per mole of hexane, and that was the number 86.178. And again, that was for the hexane compound. For the octane compound, it was a different makeup. It was 8 carbon atoms chemically combined with 18 hydrogen atoms, and that gave a molecular weight for a molecule of octane, the number 114.232, and those are measured in grams per mole. So again, we have a system of equations, two variables. We could solve it using graphing. We could solve it using substitution. To solve this using elimination, the trick is to get the coefficients of one of these variables to be opposite. And right now, the coefficients of C are 6 and 8, and the coefficient of H is 14 and 18. They're not opposite. So what we do is we use the method of multiplying both sides of the equation by some number, and that often can be the most challenging part, is to figure out what number to multiply by. But I'm going to focus on the C's again. You don't always use the first variable, but they happen to be the smallest coefficients. So I'm going to look at my two equations and try to determine what could I multiply each equation by in order to get those coefficients opposite. And remember, they don't have to be multiplied by the same number on both equations. You just have to multiply the right and the left side by the same number. So I'm going to multiply the top equation by 8. So I use my large parentheses around the equation and my smaller parentheses to indicate times, and I multiply them by 8. And in the second equation, you see it now. If I multiply 8 times 6, that'll be 48C. How am I going to get 8C to be negative 48? Well, I multiply by negative 6. And remember to put it on both sides. That'll help eliminate the error of forgetting to multiply the right side. So using the distributive property, I can rewrite this system of equations. We'll do it quickly. 8 times C is 48C. Distribute in 8 times 14H, and that's 112H. On the other side, 8 times 86.178 is 689.424. Please check that multiplication for me. So now distributing in the negative 6 to the second equation, that gives me negative 48c. Aha, just what I wanted. Negative 6 times 18h, that gives me plus a negative 108h. And on the right side, negative 6 times 114.232 is negative 685.392. There we have it. A new system of equations equivalent to the first system, but much more friendly to us, because if we now add the second equation to the first equation, that will eliminate the variable c, which is just what I set out to do. Just a quick note, a reminder, you can only add equal things to both sides of the equation. But look, if I add this quantity to the left side of the top equation, and I add this quantity to the right side of that equation, I'm actually adding equal things to both sides. They're just written very differently, but they are equal because of the equal sign. So let's do the simplifying. 48c minus 48c, they cancel. Adding these two terms together, that leaves me with a nice friendly 4h equals. Adding the right side together, I get 4.032. To solve for h, divide both sides by 4, and h is equal to 1.008, and that is going to be the atomic weight of one atom of hydrogen. To find the atomic weight of carbon, I take the value of h, go back to one of the original equations, pick the one that you think is going to be easiest. I'm going to choose the first one. So I replace h with 1.008. So I have 6c plus 14 times h, which we now know is 1.008, and that's equal to 86.178. Simplify this product. 6c plus 14.112. The right side does not change. Subtract 14.122 from 112 from both sides. That'll result in 6c is equal to 72.066. Now divide both sides by 6, and that results in c is equal to 12.011. There you have it. So now we summarize our results, and we can put those two values up here where we defined our variables. So c is equal to the atomic weight of one carbon atom, 12.011. And oftentimes you'll see the unit of measurement as just a lowercase u, and that stands for the unified atomic mass unit. You young chemists, remember that, unified atomic mass unit. And the atomic weight of one atom of hydrogen, 1.008 units. You might say, after doing all this work, that's pretty cool. Or some of you might just say, why don't I look that up on the periodic table? And sure enough, if I look at the atomic weight of hydrogen, we see that that is 1.008, which is what we came up with. And over here on the periodic table, one carbon atom is 12.00011. Cool.